The third and final method of transfer of heat is by convection. We've already studied the nice equations that we have with conduction of heat, where two objects are touching each other, and by radiation, where radiation is given off by the substance, electromagnetic radiation specifically. And now, what is convection? Convection is when we actually have air flowing from one place to another. And if we have a house here, and in the floor there's a register, and it goes down to the furnace, and our hot air comes up and it circulates and goes out some other return here, returns back to the furnace, then we would say our house is being heated by convection. Unless we had, if we were in bed and we had a thermal a hot pad or a heated blanket on, then we would, of course, be getting it by conduction. If we had bright lights that were emitting radiation, or the sun was coming in, then we could get it by radiation. But normally our furnaces are going to run by convection. Convection is the exchange of heat from one place to another by actually the movement of a fluid. And that fluid could either be a gas or a liquid. We have that convection in the movement of heat in our Gulf Stream, in the ocean. It takes a tremendous amount of heat from the tropics and the Caribbean up to the higher elevations near the North Pole and over toward England. As the convection of that water moves from one place to another in the Gulf Stream. And we also have that in hot tubs and many other places where the heat is distributed from one place to another, not by a non-moving, simple conduction method, but by the convection of a fluid. Now you can distinguish a natural convection from a forced convection. If I have, for example, a pan of water on a burner, and if I have water here, then the heat that's down at the bottom is going to rise and the hot fluid moves upward towards the top. That's a natural convection. But, for example, in ovens, we may have a heat and we may have a fan in the back. That's the latest thing in ovens, is a convection oven that actually blows the heat across the food, and it cooks it much, much faster. If you're going to cook a turkey, if you have a more expensive convection oven, it not only will be at 350 degrees, it will cook much, much faster because it's blowing that hot air over the turkey constantly. It turns out that you will be very happy to know that the formulas for convection are extremely complex and nonlinear. That's because they're fluid flows. And they really don't work very well. Engineers use some of these equations, but for the most part, you will not be responsible for anything generally on the undergraduate level where you would have to compute the amount of heat that was conveyed from one place to another because of the movement of a fluid being either a gas or a liquid. Again, those equations are very nonlinear, they're very inaccurate, and are highly specialized from one circumstance to another. Therefore, you have no equations and only descriptive material when you study the transfer of heat by convection.